Hello everyone, thank you for watching this presentation. Today I will present our research titled Manifesting Architectural Subspaces with Two Mobile Robotic Partitions to Facilitate Spontaneous Office Meetings. The idea behind the open plan layout is to foster collaboration and creativity by eliminating physical barriers like walls or cubicles. This openness encourages spontaneous face-to-face interactions among workers, which can enhance creativity, innovation, and help build interpersonal relationships. However, despite these intended benefits, research in environmental psychology reveals that the majority of workers are dissatisfied with open-plan offices as they fail to manage acoustic, visual, and privacy-related distractions. Ironically, the very spontaneous meetings meant to enhance collaboration often end up being the source of these distractions. As a result, workers may choose to avoid coming to office, which undermines the team cohesion and individual well-being. To tackle the issues seen in open-plan offices, two popular approaches have emerged: the activity-based and flexible office layouts. The activity-based office layouts organize the spaces into distinct subspaces, each dedicated to specific work activities such as meetings, focused work, or relaxation. While this seems ideal for optimizing work, the layout fails in practice. Frequent switching between subspaces disrupts workflow, distracts nearby colleagues, and limits the ability to customize individual workstations. On the other hand, flexible office layout offers adaptability by using mobile furniture elements like desks, partitions, and cupboards that can be manually rearranged. While this provides the potential for creating smaller subspaces for unplanned activities, it creates its own set of challenges. The constant need for manual adjustment can be repetitive, physically demanding, and often requires negotiations with coworkers. This not only adds to the workload but can also lead to social embarrassment. Meanwhile, studies on robotic furniture demonstrates that robotic furniture can maneuver life-size architectural elements within the shared environments. Even more importantly, it can convey specific intentions to people. In the context of adaptive architecture, robotic furniture has already been shown to reshape layout to reduce spatial distractions and improve privacy. Building on these promising findings, our study seeks to push this concept further. Instead of just demarcating a space, we aim to use robotic partitions to manifest fully enclosed subspaces that could reduce distractions. However, a major question remains: how should these layout changes be manifested, and how can we encourage workers who are causing distractions to use this space? Our primary research question is therefore, how can two autonomous robotic partitions manifest an enclosed subspace within an open plan office layout to reduce distractions originating from a spontaneous meeting? To explore this, we conducted a semi-controlled user study by deploying two seemingly autonomous mobile robotic partitions in a relatively small existing open plan office, where they could manifest an enclosed subspace by forming four orthogonal boundaries. We invited 9 groups of 3 participants to engage in their either spontaneous meeting or focused work activity, while partitions manifest subspaces based on different architectural strategies. Our semi-controlled study was conducted at the local headquarters of IDEVE, a consulting company that specializes in healthy and safe work environments. We selected a relatively small workplace as shown in the image. The office layout was carefully planned so that the two large robotic partitions could manifest enclosed subspaces without interfering with the existing office furniture. We deployed 2 identical robotic partitions. Each partition, designed with acoustic panels and wooden cladding, was built using the Keller Mobile platform for silent and reliable movement. The partitions were deployed in deployed using the Wizard of Oz method, where a researcher provided goal points via a web-based control interface, and the partitions autonomously navigated to their destination real-time. To manifest and close subspaces, we implemented 4 architectural strategies under 2 different groups. First, we have the adaptation strategies, which were designed to address distractions caused by spontaneous meetings. Next, we have the nudging strategies. These were designed to encourage workers having spontaneous meetings to relocate. In adaptation strategies, we do have 2 types. The intervention strategy manifests an enclosed subspace around the worker having the remote meeting to reduce distraction, while the mitigation strategy focuses on the distracted workers to protect them from emerged distractions. We hypothesized that participants would interpret these strategies differently based on whether they seem to attack or protect a worker. For nudging strategies, the gestural nudging strategy involves one partition performing a perpetual swaying motion to nudge the participant in remote meeting to relocate, while the spatial nudging regulates the physical and visual connection between workers to encourage them to collaborate. Both strategies aim to influence participants either through motion or spatial configuration, and we hypothesize that participants would interpret the intentions behind these nudges differently. The procedure started with a familiarization session where participants observed the robotic partitions. They then experienced 2 adaptation and 2 nudging strategies. In result, we recruited 27 participants consisting of 18 women and 9 men, aged between 18 to 64. Most of the participants had over 5 years of experience in open plan office environment. Each group participated for an average of 75 minutes of experiment. Our results show that there is a difference in preference of adaptation strategy based on the work activity. While remote workers preferred the intervention adaptation strategy as it provided better visual privacy, focused workers preferred the mitigation adaptation strategy as it allowed them to retain visual access to their colleagues and the window to exit. About nudging, participants had different preferences based on how each strategy communicated intent. Participants found gestural nudging often distracting due to perpetual motion of the robotic partitions. This constant movement, especially when the intended worker didn't move into the subspace quickly, became a source of distraction. Moreover, some participants struggled to understand the nudging intent or which direction they were being directed to. Spatial nudging strategy was better received as it made the intention behind the initiation or concluding a meeting clearer. Participants could easily interpret the emerging transit subspace and directionality of it. In summary, gestural nudging introduced unnecessary distractions due to its motion and lack of clarity, while spatial nudging was more effective in guiding participants, though it sometimes limited the sense of the control of interaction. Our study highlights the importance of managing human expectation when using robotic office partitions. Participants often found these partitions distracting when their physical design, motion, and alignment did not meet expectations. In conclusion, we suggest that purposeful robotic furniture such as office partitions should intentionally manage human expectations by design, which should ensure that its physical morphology aligns with its actual capabilities, its motion performs in a deliberate and predictable way, and its architectural arrangement manifests within spatial precision. Moreover, our results show that participants experience trade-offs between reducing and introducing distractions influenced by the type, location, and duration of the work activity. This suggests that the trade-off could potentially be balanced at both subspace and overall workspace level. Therefore, we propose that robotic furniture like office partitions can equitably balance its purposeful introduced support and inadvertently introduced distraction by distributing its manifestation based on the relative activities, distances, spatial privileges, and exposure durations of collocated individuals. Lastly, our results shows that participants found an adaptation or nudging strategy more understandable when it interacted with them indirectly through the spatial affordances of the transiently manifested subspace as opposed to the direct gestural motions. Participants naturally interpreted the spatial cues of the partitions to adjust their behavior accordingly. This suggests that robotic furniture can effectively convey its intentions through architectural affordances, making spatial nudging more intuitive than the direct gestural motions. Therefore, we propose that purposeful robotic furniture like partitions can nudge collocated occupants obtrusively and understandably by conveying its intentions through the architectural affordances that transiently regulate the area, directionality, and visibility of the space. In conclusion, our study explored the use of autonomous robotic partitions in open-plan offices to manage distractions from both face-to-face and remote meetings. We identified three design considerations: aligning robotic furniture's capabilities with human expectations, balancing distractions based on individuals' needs, and using architectural affordances to subtly guide interactions. These insights can inform design of future robotic systems, helping to create environments that support human activities, improve well-being, and enhance overall workspace satisfaction. Thank you for your time.